thought I'd talk a little bit more about artificial intelligence and machine learning. It's going to come on in the next 5, 10, 15, 20 years. So I thought I'd just talk about kind of basic concepts within machine learning and artificial intelligence, where we were in the past and where we are right now. Yeah, there was definitely a before and after in 2022, before ChatGPT came online, and then everything before that. Unfortunately, the textbook using MIS, the one we have for this class, isn't very good at unpacking what has happened over the last few years. I think it was published in 21 anyway. But I thought I'd go over sort of like get everyone up to speed over what's happening now within AI, at least within the maritime domain, and maybe a little bit what the future might look like. Okay, so in the 2010s, and before that, the concept of AI they started making formulas back in the 1950s. It's a pretty old concept, but we've come up with computing power now, so we're able to kind of leverage these models a little bit better today. I thought I'd start with a very basic understanding what machine learning is. It's not too complicated. So in the upper left here, and again, the difference between machine learning and artificial intelligence attempts to mimic human beings. Machine learning has more of the flavor of models and algorithms and kind of getting this kind of formula going to kind of get the output that you want from the model. Now there's a little bit of carryover from ML to AI, which I'll talk about in a little bit. Here on the left is a more traditional ML model and machine learning model. So in the upper left here, we have a vessel entering Houston. On the top there, where it says entering Houston model, and it has the 4 drafts. You can see the top 3 is 19 foot, 30 foot, 50 foot, and then whether it can enter the Houston Ship Channel or not. I actually don't know what the controlling draft is, but I'm just kind of making this up. What the machine learning algorithm does is it runs tests of that top layer, so the 19 foot, 30 foot, 50 foot, and it runs and it knows what the answer is. So you have predictor, which is the draft, and then the outcome, which is whether the vessel can enter or not. So the computer will iterate over this thousands, tens of thousands, millions of times, and it'll start to get an idea of like, hey, whether the vessel can enter or not based on whatever draft. So if you look at draft 25 feet, that would be something after the model's been trained properly, you could stick into the black box and then it would output an outcome. In this case, 25 foot might be, yes, it can enter. Yeah, you could say like just do a Boolean, whether it's greater than or less than controlling draft, but this is more nuanced. So you could have, again, in the bottom table, you can see this is a little bit more complex. So we might have drafts in the left column. We might have whether there's fog or not, maritime security level, and then whether it can enter or not. So now it's getting a little bit more complex. So again, iteratively, you could go over this thousands, tens of thousands, if you have enough data and enough, supporting data for this. And then you can start to make predictions based on draft, whether there's going to be fog, what the MARSEC level is, and that sort of thing, and say, hey, whether the vessel's going to come in or not. All right, so that's kind of before 2022. A lot of people were making fancy models in the maritime domain. Of course, we're like, this is a very changeable industry. And as everyone knows, like you can model it to the nth whatever, and things will still happen. So really hard to model ocean shipping, as we know, since COVID. Here on the right is the language model concept. So ChatGPT came out with 3.5 in 2022. They're up to 4 Omni now. We have different models from different providers like Facebook and Google and Microsoft. these models are pre-populated with general corpora, so they might, in the case of OpenAI, there's hundreds of billions of words in their models that they put in there, they build networks, and then they try to match semantic searches with the matches in the general language corpora. A little bit different from machine learning. So what's going on here is that if you're saying something like a human being would, like, I want to come into Houston, there's a half-mile visibility due to fog, MARSEC level 1. Can I enter Houston? What the language models are going to do, they're going to search for similarities between what you're saying. So there might be something in that general corpora where it says, like, there's already a ship that couldn't go in because of those circumstances. It matches it, and the model says, okay, no, maybe you can't come in. Something like that. So it's a semantic search. On the left, the machine learning, what's interesting to me is on the left we have machine learning, on the right we have the AI thing. But in both cases, all of the information is vectorized and converted to numbers. So there's some similarity there. What you're seeing here are not words in the databases or the data silos, are actually numbers. Everything gets converted. It's a very quantitative and numerical exercise. And then those numbers are connected with other ones, this neural network, and you're able to kind of like match semantics, type of language used, context, those sorts of things, which are embedded in the AI's database. Okay, sorry, I'm not say anything more about that. So on the right, the question is like, okay, what does that mean? What does it matter? Because a lot of people now are like, there's some people that are like, AI, these language models are going to keep getting smarter and they're going to take over the world. And then there's the other group where they're going to maybe get better, but it's going to take time, based on better hardware coming on, more language coming on. Then there's the other ones where it's kind of like currently, and I can't remember the academic study, I was just reading it, but where it might flatline from here. So that these models are as good as they're going to ever be. If that's the case, which I'm in the camp of they're not getting better, but I'm also in the camp of like they can be incredibly useful to us, and particularly in the maritime industry. And I'll talk about how that's happening right now. So here on the right, we have a large language model. We're pulling a model and we're asking it questions. Now, these AI models do a good job of answering general questions really well. So, for example, if I say I want to make a pizza, give me a pizza recipe. ChatGPT is going to give me a great pizza recipe, I guarantee it, because it's maybe got tens of thousands of pizza recipes in its corpus, and it's drawing from all those pizza recipes, so no problem with pizza. If I want to ask when should I test the emergency shutdowns on a oil tanker, it might not be so good at it, because now we're talking about a little bit lack of context, because we're talking about, a tanker where, what flag, that sort of thing. It might need more information. And then there's probably very few examples of this. I mean, you could go into like government publications, it might draw from that, but it's going to have a little bit of a harder time doing technical jobs, basically. So what's happening now and what will happen in the future, much like for those who are mariners, they're familiar with performance standards where you kind of nail down what kind of data is coming in and out, what kind of information is coming in and out, like the ECDIS performance standards is a great example. In a shipboard operational environment, we very much lock down the type of information that's coming in, because if we don't, it increases operational risk. So we have to know what kind of data is coming in and out. Similarly, with these new AI models, we have to do the same thing. So here on the right side of the screen, we have two situations. One is where we ask a question in the general model. So we just ask it as we would in the UI, any sort of model. It says general corpora, vanilla model, comes out with an outcome. So if I want to ask, can I get into Houston with a half-mile visibility? It's going to give me an answer. On the left, which is what's happening now behind the scenes, very robustly, is that people are creating their own language models. So they're creating their own co-pilots using technical material. So it forces the AI to use standardized material to provide outcomes, and this will reduce hallucination and bias, and it will produce a more efficacious answer. This is very similar in flavor to the performance standards that the IMO published. So they recognize early on that having bad information on the bridge of a ship is going to cause problems, and that's absolutely true. I would say a lot of our safety record in the past 20 years, which has been very good in the maritime industry, a part of that is having good data coming in, depth of water on the Ectus, for example. Because that information is standardized during the process of like the cartographers digitizing it, sending out through notice to mariners or whatever, and then having it eventually show up on the ship. This is a very controlled environment. Similar, these language models, to have a technical application, you very much need to create guardrails and a roadmap for how this AI is going to behave. And the way that you do that is you train it up with information that's only relevant to the question that you're asking. So on the right here, the way that this works is on the left we have different silos of information. Let's just pretend that we're going to silo Bowditch, which is the American Practical Navigator. It has all of the navigational information. If you want to know about Bowditch, you could ask a vanilla copilot, or you could create your own silo with just information from Bowditch and query that information. That will be much more efficacious than asking a vanilla chatbot the same question. What is also happening is when people build these models here on the right, where we have artificial intelligence with the different data silos, is that you want to test the efficacy of these silos or models. If I mentioned models back with machine learning, they're popping up again because this is a type of modeling. I won't get into the different styles of modeling because you have silos, you work with different types of silos. You might train the AI which silos to access. You might train the AI what questions to ask the silos, that sort of thing. So there's a lot to think about here. It's beyond the scope of this class. But you get an outcome. Say you have a siloed Bowditch and you ask the chatbot about Bowditch. It goes to Bowditch, looks up the answer, and gives you a Bowditch answer. And then on the right, you put it into the vanilla model. One of the things that people are doing now that they must do is compare the efficacy of the two responses, which you can do actually with another AI, or you can do it with human beings. In this case, this is from a project document I'm working on. I set a KPI for each model outcome so that the customers know that the model that we're making for them is superior to the other model because the quality of response is better. Okay. You can also, on the back end, record the responses, the quality responses, and then add that to like an FAQ or something and create another silo so the AI can get smarter about particular subject matter. All right, I'm running out of time here. This has been a long conversation, but I just thought I'd kind of go over this with you guys. Probably in the following week, I'm gonna continue on with this AI ML talk because it is in current events. It's visible and something you should definitely know as a manager in the maritime industry. Just kind of the differences and the nuances and the sensibilities of how AI is being used today in the maritime space. All right.